all, in today's session we'll talk about the radiation intensity. Now let us see the definition of radiation intensity first. What do you mean by the radiation intensity? So the radiation intensity is nothing but the power radiated from an antenna per unit solid angle. So as we know that this is nothing but the power radiated by an antenna per unit solid angle, we can give the unit of this particular radiation intensity as watt per steradian. Now how we can calculate the radiation intensity? Now you can see that your radiation intensity can be calculated or can be obtained by multiplying radiation intensity with the square of the distance. So this will be the r square radiation intensity. So this is all about how we can calculate the radiation intensity. So now let us see each and every term related in this particular formula. So U is nothing but the radiation intensity. Now as this is the, you can say, the power per unit solid angle, it will be watt per steradian. Now this W radiated, that is radiation density, as we have already gone through the radiation density in the previous session, you can say the radiation density unit will be the watt per meter square. Now the radiation intensity here, as we know that previously we have gone through the radiation, you can say the density, it is dependent on, this depends on the distance from the antenna. But here when you talk about the intensity, it is independent on the distance from antenna. So here you can say it is dependent on the distance on the antenna and it will be independent on the distance from an antenna. So this is all about the radiation density and the radiation intensity. Now let us see how you are going to find out the radiation intensity. Now previously we have gone through one of the formula for the radiation density, that is nothing but the W average. You can say that W radiation and the W average is same as we have seen previously, will be E square 2 neta AR. Okay, now let us put this particular value in this particular equation. Whenever I am talking about the radiation intensity, you can say that this U is equal to R square 2 neta into E square. So this is nothing but the radiation intensity, you can say, in terms of the radiation density, as we have used the radiation intensity. Now here let us talk about the power radiated. Now how you can relate your radiated power with the radiation intensity? So we can say that your radiated power can be calculated by using the radiation intensity. So I'll write here P radiated is equal to the integration over the closed surface to that particular solid angle. So here if I put all that things, now I know that this d ohm is nothing but the solid angle or incremental solid angle will be sine theta, d theta and a d phi. So I'll put that value over here. So this will be the sine theta, d theta, d phi. Now here we know that this d ohm or is nothing but the incremental solid angle, and where you know that P radiated is nothing but the radiated power. But if I say this is the first formula for the radiated power, we can say that our power radiated we can define in the radiation density also. So P radiated is equal to integration, you can say, power density and the incremental surface. So here you can calculate the radiation intensity, radiated power in terms of the radiation density and in terms of the intensity. Now let us denote this equation as the equation number 2. So the radiation intensity is also used to express the normalized power. How we are going to find out the normalized power in terms of the radiation? If you know the radiation intensity, I can calculate the normalized power, which is nothing but the Pn theta 5 is equal to U theta 5 divided by U theta 5 max is equal to, otherwise in the radiation density you can say, so theta 5 divided by W theta 5 max. This means that this is nothing but the function of theta and 5. Now for more understanding of these parameters, let us see the power radiated, or you can say the isotropic radiator is radiating, and you need to find out the radiation intensity for isotropic radiator. So here if you are talking about the isotropic radiator, we know that our isotropic radiator radiates equal amount of power in all the directions. So here my assumption is that my radiator or my antenna is an isotropic antenna, whereas I need to calculate the, I can say, radiation intensity. So it will be U0 d ohm. So here I am assuming that U0 is nothing but the radiation intensity of isotropic antenna. So here I am assuming that my antenna is isotropic, and isotropic antenna, or you can say the radiator. So how we are going to calculate this one? So I'll put all that things. So as we know that this integration is 5 is equal to 0 to 2 pi, and your theta will vary from 0 to pi. So u0 sine theta d theta d phi. Now we know that our incremental solid angle d ohm is equal to sine theta d theta and d phi. Now let us find out the integrations for each and every term here. Now this e0 will be constant, so I'll put that u0 here, and then sine theta 5 will vary from 0 to 2 pi, and you can say sine theta integration will be minus cos theta, varies from 0 to pi. So if I calculate all these things, I can get this is nothing but the 4 pi u0. So I have calculated the radiated power. If I know what is the radiated power, I can calculate the E0 in terms of the radiated power. So therefore u0 is equal to P radiated by 4 pi. So this is nothing but the radiation intensity for an isotropic radiator or for an isotropic antenna. Now this result is very obvious, as we know that our isotropic antenna radiates equally in the all direction, that is 4 pi steradian. Thus the radiation intensity is simply obtained by dividing radiated power divided by total steradians. So this is nothing but the how we can calculate the radiation intensity for your isotropic antenna. So we'll stop here. Thank you.